My name is Michiel Spape, or Michiel Spape. I'm from the Netherlands. I'm an adjunct professor. I'm here representing the Helsinki team for Virtual Times. I'm a cognitive neuroscientist and a cognitive psychologist working in the area of perception, action, integration, cognition, consciousness, these kind of things. So as a psychologist, I'm kind of interested in these kind of fundamental questions like what is consciousness, why do people do what they do, what is intention, what is free will. If you do that, somewhat inevitably you start using or looking towards the brain as the fundamental unit of your explanation. So then gradually I've also moved towards cognitive neuroscience, and generally that has meant for me the study of EEG, so electrical study of electrical scalp potentials originating from the brain. So as the neurons fire, if they do that well enough at the same time, you can pick it up at the scalp, and that's what we measure. So I am coordinating, so to speak, the two Helsinki teams. We have basically two sub-PIs working on this project, Professor Giulio Iacucci at the Department of Computer Science in the University of Helsinki, and Professor Niklas Ravia, Professor in e-health at the Department of Psychology and Logopedics in Helsinki. So the one has a more psychology-oriented approach, and the other one a more computer science approach. And because it's quite hard for everyone else in the team to think of us as two units, I try to communicate between the two and get us all in a kind of single program for the virtual times aspect. So that is what I do, management or team-wise, I suppose. What I do otherwise is I do research in virtual times, and yeah, we do research about how to manipulate time perception. This is to me also a kind of the critical question. Like, we can all think of so the central thesis of the Virtual Times project, as you know, is that distinct psychopathological disorders have temporal characteristics. That is to say, people with depression feel stuck in time. People with ADHD may feel that time is going too fast or too slow for them. So these kind of temporal disturbances, if you think that they have some sort of causal aspect, so maybe it's not that the depression is causing people to feel stuck in time, but maybe the feeling of stuck in timeness is not causing the depression. It's possible. It's kind of a unique hypothesis of the project. If this is so, then you might want to do something about it. But how do you change time perception? There are all sorts of ideas about how it might be possible. Typically, people think that that time perception is organized as a sort of central clock somewhere in the body, and if people are feeling very aroused, the clock goes ticking faster, and if they're relaxed, the clock goes goes slower. And if you put your attention towards the clock, then you feel time passing. That's one idea. So from an interventional point of view, you try to, make people aroused or relaxed in order to change time perception, or just say don't bother with the clock. To me, this kind of misses the point. I think that time perception is not just about looking inwards and perception, but also about what people are doing. So according to me, perception is fundamentally about exploring our environment being in an environment and moving within it. So if I'm moving from one point to another, I get information about how much time has elapsed. If I know how much time it normally takes, and then I guess that so much time has happened. Similarly, if I even make very small movements, like I move my eyes somewhere or I move my head, then there's fundamentally restricted aspects of time in there. That is to say, normally I've moved my head and it can't be done instantly. So my system, my body knows how long it must take. And according to me, from these kind of aspects, you might be able to get some sense of time. And normally, of course, you can't do anything about this. That is, if you move your head, the vision changes, but it doesn't change different in time. It's not like you can move your head any faster than normally. But in virtual reality, you can do something about it. So what people quite often do in virtual reality is they give you different sort of stimuli. So nice virtual worlds. In our project, we have people making the sun go up faster and slower. But I thought that maybe we can do something different. Perhaps we can make the visual stimulus kind of drag behind our own movement. So if I move my head to the left, we had a project that perhaps this visual stimulus can be delayed in time. So with that sort of difference between our motor action and our sensory feedback to it, I thought that maybe we can change time perception. And this kind of thinking I've continued approaching more or less. So one kind of successful project we had in this that was much easier than doing this old head motion tracking stuff was to ask people about imagination. So to have people imagine moving faster. And it turned out if you ask people to imagine moving faster and you show them a timed video, say of 10 seconds, then they time it also faster than they normally do. So they start to overestimate the amount of time. This shows to some extent that our imaginary action changes our perception of time. So time perception is not just about attention and arousal to me, but it's also about how we move and our sensory feedback to these movements. Yeah, so as you say, you cannot go too far with this head movement distortion sort of aspect. What else could we do? So I was thinking that maybe we can do something with this imaginary movement and make that cause certain changes in our environment. So instead of having people move their head and then different aspects of the environment change, I was thinking that if people imagine movement and we can somehow detect this and change our environment based on it, then maybe we can also change time perception. So we have this project in which people are imagining moving faster and faster, or they imagine just standing still. And using brain-computer interfacing, we try to detect their imaginary movements. And based on this imaginary movement detection, we show star fields speeding up. So basically people are floating through space in virtual reality. They're imagining moving faster and faster, and then they see stars going faster and faster towards them. At least that's the idea. So they get the experience of being able to organize their own speed through the stars by imagining themselves doing so. And of course, this, according to me, this should change time perception, and it does. So that's that. Or at least the imaginary movement themselves, as I had said, seems to change their time perception, but we also have some sort of preliminary results, still need to publish, that show that the passage of time, that I'm sure Kai, Vogler, and others have talked about, is also changed, especially when the visual movement is related to your imaginary movement.
Mm-hmm.
So that's more or less how we use brain-computer interfacing and machine learning to change visual perception, and through that change time perception. Management-wise, it's very hard to keep everything coming together and have every part communicate with every other part. In terms of practical application, there's still a huge step that needs to be done, not just in order for people to momentarily change time perception or to diagnose these time perception aspects, but also to make lasting changes, of course. So if you are doing intervention therapy and you are managed somebody to to adjust their clock by, say, 10% over the course of an experiment, I would be very doubtful that that change is going to stay there for any length of time. So if you mean to make a meaningful therapeutical instrument, you obviously want something like your exposure therapy, that at some point people no longer fear their particular phobia. And right now we are still at the stage that we would be very proud if we can even make momentary changes in time perception, because I think that's not been done. Then the next step would be to see if that has any consequences for psychopathology, and the final step is then to see that it continues working for longer or therapeutic use. But maybe it's simpler than I think. I'm not a clinical psychologist, so I'm still there with the first step. Right now, I'm very proud of my imagination task. So we have already shown a bunch of time that this imaginary movement, even without virtual reality, changes time perception. But somewhat recently, there's also been a big meta-analysis that showed that depressivity, the biggest disorder out there, and also the most obviously related one to time perception, has no clear relationship with experimental tasks of time perception. So a lot of patients say that or describe temporal disturbances, as others have noted, but we have not been able to correlate these with actual differences. But of course, if you think about it, it's very hard to do that. For example, if you ask people, say with a task, telling them like this is a long interval, beep, beep, and this is a short interval, beep, beep. And you try to discriminate these two intervals, and that's a typical kind of time perception task. So you might imagine that people with depression would have a more longer discrimination between the two or not. But the problem is, of course, that let's say your subjective second is shorter than somebody else's subjective second, and it's very hard to say that your frame of reference would be different. So the beep would be an even shorter beep than the very long beep. So what I'm meaning to say is that it's very hard to show any such relationship, objective time perception and psychopathology, because people with shorter or longer subjective seconds, so to speak, will show that in every single experiment. The entire results will just be biased and you shouldn't be able to see it. And now with our imagination task, we've found that the amount of depression symptoms was correlated with the effect of imaginary movement on time perception. So rather than having a direct effect of depression on length of time or amount of subjective seconds, so to speak, we found a kind of a mediation. So the amount of, let me rephrase that. People who had more depressive symptoms showed stronger interference of moving slower and slower. So normally people imagine moving slower and slower. Also count the same interval as shorter, as fewer seconds, so to speak. And people with depression have an even stronger effect of that. So rather than people with depression not being able to imagine things, they seem to be stronger able to imagine their movement, or at least it has a stronger effect on their time perception. And I thought that was very cool because it's, as far as I know, the first time there's a real effect of experimental time perception task in terms of psychopathology.